Here is the graph we have, and the corresponding equation f of Kim is equal to 1 over 13 Kim cubed. The Kim trinity plus Katie asks us to find the arc length of f of Kim from 0 to 3. First, we must find a derivative of f prime of Kim, that being f prime of Kim is equal to 3 over 13 Kim squared. From there, we must find the squared value of f prime of Kim, that being f prime of Kim squared is equal to 9 over 169 Kim to the fourth power. This is the equation to find the arc length of a given function of f of Kim between two bounds. Knowing the given bounds are from 0 to 3, a would be 0 and b would be 3. Also knowing that the squared value of f prime of Kim is 9 over 169 Kim to the fourth power, or to simplify it out, we could take out 1 over 13 outside of the squared parentheses, which would give us a value of 9 Kim to the fourth power. All we gotta do now is integrate. The arc length of the given equation, f of Kim, is equal to 1 over 13 Kim to the third power in between the bounds of 0 to 3 is estimated to be around 0.00283603515, or to the nearest thousandth place, 0.002.
Next, we will do integration by parts. First, we need to identify the u and the dv parts of this function, and we can determine this using the tool limit. Limit stands for log, inverse trig, polynomial, exponential functions, and trig functions. It determines which function will be the u. This particular function has a polynomial and a trig function, but because polynomial comes first in the limit tool, x, the polynomial, will be our u. The cosine x will be the dv. Next, we will set up a 7 and put a horizontal dash through the middle of it to remind us to subtract later. We will place the u, or the x, at the top left of the 7 and put our dv, cosine x, at the bottom right of the 7. Now we can solve. Take the derivative of the u, which is x, to get du, and put that derivative at the bottom left of the 7. Now take the integral of the dv, cosine x, to get v, and put that integral at the top right of the 7. Next, we will multiply the top left and top right functions together, and then subtract the integral of the product of the top right and bottom left functions. To fully solve this problem, we will then solve the final integral and add a constant c.
Learn about improper integrals. Let's find the integral from 0 to infinity of 1 over Kim squared plus 1 d Kim, where Kim is a variable, just like x. Because the bounds are not finite on this integral, we need to find another way around finding the integral. So, let's change the format. We will use improper integrals to solve this equation. Change the equation to be the limit as a approaches infinity of the integral from 0 to a of 1 over Kim squared plus 1 d Kim. Next, we solve the integral. We know that the integral from 0 to a of 1 over Kim squared plus 1 d Kim will be equal to inverse tan of Kim from 0 to a. Continue solving the problem. Because we know that a is approaching infinity, we can replace the a in inverse tan of a with infinity. If you solve inverse tan of infinity minus inverse tan of 0, you would get pi over 2 minus 0, making the answer pi over 2. Because this answer is a finite value, we know that the integral converges, while if this answer was not a finite value, the integral would diverge.
Hey guys, so I'm going to be talking about polar equations, and we know that polar equations define an algebraic curve that's basically just expressed in polar coordinates instead of rectangular coordinates. So in order to convert from xy to r theta, we have the two equations, x equals r cosine theta and y equals r sine theta. The general equation that we use to define the area enclosed by polar curves is a equals 1/2 integral from alpha to beta r squared d theta. So now that we've looked at the graph, we should try finding the bounds. So we set the equation 4 cosine 2 theta equal to 0, and we divide out the 4, and we know that 0 equals cosine 2 theta. And we know that cosine is 0 at two places, at pi over 2 and at 3 pi over 2. So we set 2 theta equal to both of these values, and we get theta equals pi over 4 and 3 pi over 4. So now let's set up the integral. So we have a equals 1/2 integral from pi over 4 to 3 pi over 4 of 4 cosine 2 theta squared d theta. When we punch this into the calculator, we should approximate 6.283. Now we're going to solve this problem that involves two different curves. So we have r equals 3 sine theta and r equals 2 minus sine theta. So now that we've looked at the graph, we're going to find the bounds. So we set these two equations equal to each other. 3 sine theta equals 2 minus sine theta. We could add sine theta to the other side. We get 4 sine theta equals 2. So we get sine theta equals 1/2. And we know that sine theta is positive 1/2 in the first and second quadrant. So theta must be equal to pi over 6 and 5 pi over 6. Okay, so now let's set up the integral. So we know that area is equal to 1/2. We know our bounds are pi over 6 to 5 pi over 6. And we know that the big curve in this equation is 3 sine theta, and we square that, and then we are going to subtract area enclosed by 2 minus sine theta squared d theta. And when we punch this into the calculator, we should get 5.196.
Thank you guys. See you later.